Hello everyone, I'm Nirmal Fernando, and I'm going to speak about a bit about the Apache Stratos 4.1.0 M1 developer preview. Uh, so as you know, our mailing list we have communicated that in the M1 developer preview there are two main features. One, the uh, most new feature is the support for Google Kubernetes, uh, and as well as CoreOS and mainly the Docker support. Uh, so before going into how Stratos has integrated these new bleeding edge technologies, I'll go through a few concepts of Google Kubernetes. So Google Kubernetes is a kind of a Docker management tool which was built at Google, and they released it recently as an open source project. And there we have a concept called Kubernetes master and set of Kubernetes minion nodes. So in the master node, they run a Google API, Kubernetes API, and some other controllers to manage Docker instances. And they have three main concepts in Google Kubernetes. One is Kubernetes Service Proxy. It's kind of a load balancer. Uh, and yeah, let me start from that. Very bottom unit of Google Kubernetes. So it's the pod. Pod represents one or more Docker instances. So you can create a pod using a Docker image, then and kind of group several Docker instances. Then you have this concept called replication controller, where you can replicate a single pod across the host machines, and you can basically you can provide high availability for the Docker instances that you're gonna deploy. And then we have the Kubernetes Service Proxy, where it, Kubernetes Service Proxy would load balance among the pod entities that has been created across host machines. So those three are the main concepts. I think this presentation is not about introducing Kubernetes for you guys. So probably we can have another session where we would go more into more details about Kubernetes later. And I'll go through how Stratos and Kubernetes work. You all know that in Stratos we have a concept called a cluster. When you subscribe to a cartridge, you would get a service cluster, right? And so we have mapped a service cluster with a set of Kubernetes entities. So when you subscribe to a Docker cartridge, you would so Stratos would create a Kubernetes replication controller, which has reference to the Kubernetes, which has reference to the Docker images that you have provided for the configurations. I'll go through the configurations in a few minutes. And then we would, by creating a Kubernetes replication controller for each of the clusters, we would essentially create Kubernetes pods that would handle by Google Kubernetes engine. So, and Stratos would additionally create a Kubernetes service proxy as well, so that we only need to know about the Kubernetes service proxy in order to access the Docker instances. So in the M1 developer preview, we mainly focused on the single machine, local machine deployment, and we have Apache Stratos running, Apache ActiveMQ running, and a Kubernetes CoreOS host cluster running. So Kubernetes CoreOS host cluster contains a Kubernetes master node and two Kubernetes minion nodes, as well as a discovery service, which is again a CoreOS concept. So, and yeah, let's go into the main subject of this presentation. It's how you can test the M1 developer preview. So we just created the tag as well. Remember, this is like, we are still in the very early stages, so you could find a lot of issues as well. So please, kind enough to report them. Uh, so here we have created a, hold on, let me share this command line. So we have created a very comprehensive user guide where you could start from scratch, like start from nothing, and then kind of test the M1. Hold on, I'm still struggling to share the screen. So you guys can see my screen, right? Yeah, I think so. So this is my Vagrant Kubernetes setup. So this I've already kind of started the Vagrant scripts and created 4 Vagrant VMs. So when I issue Vagrant status, I could see that there are 4 VMs running on my machine. One is discovery, which is used to kind of cluster master and 2 minion nodes. And there's a Kubernetes master node and Kubernetes minion 1 and minion 2 as well. So I'm going to SSH to the Vagrant master node. Inside the Vagrant master node. So Kubernetes provide a command line tool where you could kind of call the API via command line tool. So first, I've done one other thing into this setup. I've loaded a Stratos PHP image that we have created. So you can see the Apache Stratos PHP 4.1.0 M1 image is already being loaded to the master node as well as to other minion nodes. And when I issue yes, I should be able to see all the Docker instances running on the master node. But currently I don't have anything, so I can't see anything. And so these are the Kubernetes tool. This is the Kubernetes command line tool, kubecfg. So I explained about 3 Kubernetes concepts, and this is how you would list the pods. Currently I don't have anything. And this is how you list services. This is how you will list the replication controllers. So you can see that I don't have anything running in Kubernetes master node. So the API server is running only on the master node, not on the minions. But the Docker instances could run in any of the machines. It can be master or minions. I have started Stratos as well. This is Stratos console, and let me go through the JSON files that are important in this scenario, in this demo. So I have the Kubernetes. So there are a few steps that we need to do. We have included them in the testing guide. First step is to register the Kubernetes CoreOS cluster that we have created with Stratos. So for that, we have introduced a new API to register Kubernetes clusters, and this is a sample request JSON we would send to Stratos REST API in order to register a Kubernetes cluster. So you can see that I have Kubernetes group ID, and then I have Kubernetes master information, Kubernetes. So this is the master node, and it has the IP of 172.16800. So you can see I have given that here as the host IP address. And another important thing is the port range. So this is the port range that would expose from the CoreOS cluster to outside. And then I have set up Kubernetes hosts registered as well. I have my Minion 1 registered and Minion 2 102 registered. So this is a sample registration JSON, and this is again the sample. This is the kind of a curl request, how like you would use to deploy Kubernetes host cluster. So you post to this particular request path, and then the other important thing is the PHP Docker cartridge JSON file. So it's kind of the same cartridge JSON that we had with the VMs, but with few minor changes. So we have introduced this deployer type uh, attribute to the JSON, and in the Kubernetes case, if you want this to be a Kubernetes Docker cartridge, you should specify the deployer type to be Kubernetes. And this is my port mapping. It's same as the VMs. And we have introduced another new section called container, where you would specify the image name. So currently it's the only important thing that we need to specify. So if you can remember, this is the same image name I had in my cluster, Apache Stratos PHP 4.1.0 MR. And this is basically the cartridge definition, and then I have subscription. Again, it's similar to what we have with the VMs, but with few additional properties. So when you subscribe, you have to mention you have to select the Kubernetes host cluster. So there can be multiple Kubernetes host clusters registered in with Stratos, right? And by using this property, you would select the Kubernetes cluster, and then you would need to specify the Kubernetes minimum number of replicas that you need. Like, so the concept of replica is like, if you can recall, I introduced a Kubernetes entity called Kubernetes replication controller. So a replication controller would uh, list like would take a number of replicas as the argument, and then would replicate a single pod using a pod template across the host cluster. So this is that particular number. So once I deploy this in my once I deploy this, I should see 3 pod instances scheduled across my Kubernetes host cluster. And I, in the Docker case, since we do not use Puppet uh, for the orchestration stuff, we have to pass MBIP as a payload parameter. So this should be your machine's IP, private IP, and this should be accessible from within CoreOS cluster as well as from within Docker instances running on the CoreOS cluster. And then we also need to specify the message broker port. So you might, if you are familiar with our VM deployments and 4.0.0 release, you might wonder what is this new port. So recently, GAN has implemented the MQTT support to Stratos, and with the MQTT support, now we would communicate with the message broker using 1883 port. And we have to pass CPIP. CP also running in my single JVM instance of Stratos. So I have specified the private IP of my machine and also the CP port. Yeah, that's all we need in the subscription JSON. And I have a script to kind of deploy all these JSON files that I just explained with a sleep of 10 seconds. I'll just run this so that we could see, we could hopefully see Kubernetes entity starting up. So this is in verbose mode, that's why it's printing stuff. But so you can see now the Kubernetes host has been registered with Stratos. You can see the, and now we can see that the cartridge has been deployed successfully. And the cartridge type is PHP. And now you can see that the subscription has been made for the PHP cartridge, and then Autoscaler has created a Kubernetes cluster monitor where it would like monitor the health and the number of Kubernetes entities created for this particular cluster. So in the M1 developer preview, we have not focused on the autoscaling aspect. So this setup with M1, if you try with M1, it could not autoscale based on the load of the Docker instances. So now the cluster monitor has been created and could eventually ask the CoreOS cluster to create the Kubernetes entities. So now you can see that Kubernetes entities successfully starting up. So let's go to the Kubernetes master node and see whether there are entities. So Stratos would spin two entities mainly. One is replication controller for the cluster that we have created. So you can see the cluster. This is the alias I have given, and this is that. This is basically the cluster ID. And you can see the replicas. This is the minimum number of replicas count that we have specified in the subscription JSON. And also Stratos will create the services, a service for this particular cluster, and you can see that it also has this my PHP as the ID, and this is the kind of important thing, the selector. So in Kubernetes we have this concept called label queries where when you deploy a service proxy, it would execute a label query and find the pods that it would need to load balance. So you would understand it when I list the pods. So one other thing is this service proxy that has been created has 4500 as the port. If you can recall, in the Kubernetes host registration JSON, we have specified the port range as 4500 to 5000. That's why it gets the 4500. And if we list the pods, we, we can see like three pods running, but they have not been scheduled. So this is currently we have a known issue with the Kubernetes cluster setup that we are using. There was an issue where the scheduler stopped working suddenly in every 5 minutes, like there's a etcd watch close. But I heard yesterday that Kubernetes have fixed that issue and it is available in the latest binaries. So we would probably integrate that fix in the in M2. So let me restart the scheduler. So we have mentioned this issue in the troubleshooting guide that we have created to 410M1. Let me restart. So if you face this issue, just do a restart like that. Now you can see that it's getting scheduled, right? And you can see that each of the pod uses the image that we have given, and also they have the labels with the cluster domain, cluster ID. So let me list the services and how the service proxy would load balance to a subset of pods available. So here in the selector we have mentioned my php.php domain. This is the cluster ID, and this is kind of a label query. So selector would run a label query across the host machines and would find the pods which has this particular label. So if you just manually look at this thing, you can see that this has my php.php domain, and we have 3 pods running with the same label. So this means this particular service would load balance into these 3 pods. So you can now see that all the 3 pods are in the running state. That means the pods has been started successfully. And in the Stratos, you could see that. So this is probably an intermittent connection issue with the MB. But we have already received the member activated event. So it should be so you can see that member has been activated. And Stratos has received the member activation events. And we can now access, we can check the Docker processors as well. So you can see now we have Docker instances created in the master node, since there's a pod being scheduled to master node. Let me SSH to a minion as well, just for reference. So this is inside a minion, and if I Docker PS, you can see that my Stratos PHP image is up and running. So now let me switch to my browser and access the service proxy via this 4500 port, and with the Kubernetes master IP. We can access with any IP in the Kubernetes cluster. So hope you can see my screen. You guys can see my screen, right? No?
Nirmal, I think screen is not shared yet.
Okay, let me try again. So I have some troubles of screen sharing at the moment. So I think I'll re-log in. So you can see my screen, right? And so I'm going to access the I'm going to access my PHP cartridge using 4500 port, and you can see that I'm inside my PHP cartridge, and I can see the stuff that has been deployed. And so here I access via Kubernetes masternode. I could access via any of the Kubernetes host. Since I'm running like 3 replicas, and all the 3 hosts has the service proxy being deployed in them,